Alright, hey, what's up everyone? Just a little bit of an update. I couldn't manage to post a video last week because I lost my voice, so I did a blog instead. If you want to check that out, hit the link below. But I am back this week with another tutorial video, this time on implicit differentiation. Hopefully my voice doesn't lose out along the way, but aside from that, enjoy, or try to enjoy. Let's move along to implicit differentiation. Implicit differentiation is just one of those differentiation techniques that will help you to differentiate, find the y dx, the derivative function, for some odd looking equations. For example, this circle equation right here, x squared plus y squared equals to 1. There are other types of equation that looks really hard, you can't derive it normally. So instead use implicit differentiation. We'll look into this easy example first and then we'll move along into some more challenging questions. Right, so circle equation x squared plus y squared equals to 1. When you want to find dy dx, so that's the gradient function, dy dx, you have to derive the left side and the right side as well. And to do that, we derive both sides in terms of x. You can derive them in terms of y if you want, but usually it's better to do in terms of x. How we write that is we have d dx x squared plus d dx y squared, because you're deriving all the terms in your equation, d dx of 1. Right, so if I want to derive x squared in terms of x right here, then what do? Well, derive it normally. We get 2x. And of course, for 1, we just get 0. Nothing hard. That's just normal derivatives. But when we are deriving y squared, that's another variable, y squared, y, in terms of x, we cannot just write 2y, because that only works if we're deriving d dy y. So if we're doing d dy of y squared, then that would be 2y. The problem here is it's d dx. So we have to think of something else. It can't be 2y. So the way you would do this is, okay, we take a little bit of our knowledge from chain rule to help us do this. That means if you want to find d dx, then you can go d dy of y squared multiplied by dy dx. If we do that, let's have a look. D dy, if I multiply that by dy dx, then the dy cancels out. That's using a little bit of our chain rule to help us, the cancelling out of the terms, the derivatives. And we end up with d dx, which is what we need, d dx y squared. So in this case, instead of writing d dx y squared, you can write d dy of y squared multiplied by dy dx. After that, you can just derive normally and you can find dy dx, and we'll see how that works. 2x plus d dy y squared is just 2y. You can do that normally, but you multiply by dy dx, because that's what it came out as the chain rule. And then dy dx, obviously we just have to use algebra to solve for it. Bring 2x to the right side, we get negative 2x, and we divide the right side by 2y. At the end of the day, our derivative function dy dx is negative x over y. Now in this course, you don't have to sub in y, you don't have to sub in the y in terms of x. Yes, I know it's dy dx in terms of x, but you can just leave this as your answer and you'll be perfectly fine. Okay, let's move on to a harder question. Over here, where we have this equation, y squared plus xy minus 2x squared equals to 4. And we have to find the gradient at the point 1, negative 3. So this equation is, you can't derive it normally using just finding y on one side and then putting x on the right side and deriving. In this case, we have to use implicit differentiation. Whenever you see these type of questions where you have x and y on one side and you got y squared and x and y together, that's when you know implicit differentiation. Okay, so let's try to derive this. Y squared, if you want to derive, once again, it's d dx you have to derive in terms of x on both sides, on all terms as well. D dx, oops, 2x squared. We have the minus here already, so you don't have to put the minus inside. It's up to you really. And d dx of 4. Okay, so when we are deriving y squared in terms of x, as in the previous question, you just derive y normally. That means d dy y squared multiplied by dy dx. That's always the case when you're deriving y in terms of x. And over here we have d dx xy. Now we have x and y together. How do you derive that? Well, if you think about it, we have two functions. One is x, you can call that fx, and one is y. You can call that gx. If you have two functions multiplied together and you want to derive, then we end up with product rule, where you have f dash x multiplied by gx. So I'll use a small eraser here to drop that out. Plus fx, so you don't derive the first function, multiplied by the derivative of the second function. So that's how you would have to use product rule. So in this case, let's apply it there. Keep in mind that we're deriving in terms of x. If I derive x, I get 1, but then that's the f dash x, then I multiply by gx. Gx is y, so I just get y, that's it. That's the first part. F dash x multiplied by gx, I get y. Afterwards, I derive gx, so I need to get the derivative of the second function, gx. If I want to derive y in terms of x, once again, it's just use your implicit differentiation. D dy of y multiplied by dy dx. If you're deriving y in terms of x, that's what we should get. Then don't forget that we have to multiply by fx, which is the first function, and that's just x. And afterwards, derive normally, minus d dx of 2x squared, that's just minus 4x, and deriving 4 is just 0. Okay, let's start deriving. D dy y squared, we can do that. 2y times dy dx plus y by itself plus x times y dy dx, because when you are deriving, oh no, that's not x times y actually, my bad on that. D dy of y is just 1, and of course 1 times dy dx is dy dx multiplied by x, and that's what we have. X times dy dx, then minus 4x equals to 0. Of course, you group the dy dx together. Dy dx 2y plus x. So if you group the dy dx together, we get x plus 2y inside the bracket, and you have 4x minus y on the right hand side. Dy dx would then be 4x minus y divided by 2y plus x. Afterwards, we're not done with the equation, we have to find the gradient at this specific point. So you sub in the point. Sub 1, negative 3 inside your equation, and we should get 4 times 1, that's what our x value is, minus 3, divided by 2 times minus 3, plus 1, and at the end of the day, we should have 4 plus 3 divided by negative 6 plus 1. And then at the end of the day, you should end up with 7 over 5, and you have the negative in front. So your gradient at the point 1, negative 3, when you derive this equation right here, you should end up with negative 7 over 5. And that's pretty much it for implicit differentiation. Thank you for watching, and I'll see you next week.